The idea of using ultrafiltration hollow fiber membranes for water purification comes from François Feisinger, research director of the company Lyonnaise des Eaux in Paris. We met here in Toulouse when research had already been carried out on ultrafiltration hollow fibers at the Laboratoire de Génie Chimique to figure out how to make it work. François Feisinger's idea was simple: to revolutionize water treatment by replacing sand filters by membranes. We then established the membrane laboratory on January 1st, 1986. The program was simple and clear: to build within 3 years a water treatment plant using the membranes that we were going to produce, and to invent a process running 24 hours a day, 7 days a week. The very first plant, Amancourt, established in November 1988, turned out to be a first worldwide success, I'd say. Shortly after that, other plants were built based on this one. 4 to 5 months later, we started Douchy. The original modules of Douchy lasted for 12 to 13 years, I think. The first 5 to 6 plants were built up mostly in France, benefiting from the Research Foundation. As researchers, we have made improvements and installed production tools, etc. It is also worth noting that when we started the project, all the competition or producers of membranes that we visited found this idea totally wacky. While nowadays there are thousands of plants operating on the principles that we invented in Toulouse in the mid-80s. These plants are now supplied by membrane manufacturers that have increased to several dozen in number. The market is international, with large membrane manufacturers not only on the American continent and Australia, but also in Europe. Today there are 2 companies in Toulouse who play an important role on the market. This technology was initially designed for city drinking water, but it has now penetrated a lot of other domains of activity, such as residential or industrial water use, small community water supplies, and emergency water purification. Today, there is no better technology than the membranes to produce emergency water for NGOs, the military, etc. In France and in Europe, it is necessary to continue research on this subject. Although products that meet water quality requirements are available, studies in process improvement are required in order to deal with constraints that can vary. Nowadays, the energy constraint has become a key issue. Therefore, it is necessary to continue to work on this aspect. At Toulouse, at the Laboratoire de Génie Chimique, and at INSA, there are now more than 20 PhD students whose thesis topics concern membranes. Research topics in the field of membrane science have multiplied due to the success of innovation. Research often or sometimes leads to innovations. Vice versa, innovation also induces new research. When an innovation has become a commercial success, research on the topic is amplified. That is what we observe today, not only at the Laboratoire de Génie Chimique and at INSA, but not only in Toulouse, also in many laboratories in France and around the world.